So now we're looking at other trigonometric functions. So I'm going to take a look at circles again for this. And I'm just going to start off with quadrant 1. Some kind of arbitrary angle, theta there. So far we know that for some radius r on a circle, given an angle, we define the sine and cosine related to this point here. That point has an x value, y value. We can make the corresponding right triangle. That is the y value. And this here is the x value. And so far, we know that the cosine of that angle is defined to be the value of x divided by the radius. The sine of theta is defined to be the y value over the radius. And if from the unit circle, r is 1, it's just x and y. So if this were the unit circle and I change to r equals 1, then this distance right here is also the sine, and this distance right here is also the cosine. Check this out. Draw a perpendicular line from the intercept of the circle at the x-axis. So that line right there hits right there at the point 1, 0, and then intersects up here at a new xy value. So I'm going to call that point x2, y2. It turns out the length of this new green line right here is the tangent of theta. And then if I go from that point all the way back to the origin, that length right there, and I'll prove this in a minute, turns out to be the what's called the secant of theta. So in a relatively simple picture with a circle, an angle, two similar triangles, we get sine, cosine, secant, and tangent. So first I'm going to tell you a little bit more about secant and tangent, and then I'm going to show why this picture that those lengths are calculated by those two trigonometric functions. So just like we define the cosine of an angle to be the x value over the radius and the sine to be the y value of the radius, the tangent is defined for some angle to be the y value divided by the x value at the point for which that angle and ray create on the unit circle. And the secant is defined to be the radius divided by the x value. Now, notice radius divided by x value versus x value divided by radius. They're reciprocals. So that means the secant and cosine are reciprocals. So another way I could define the secant is by saying it is also 1 divided by the cosine of the angle. Also, if you were to take the sine and divide by the cosine, the r's in the denominator divide out, and you would get y over x. So an alternative way to define the tangent is it is the value of the sine of that same angle divided by the cosine of that same angle. So again, things to memorize. Cosine of an angle is the x value divided by the radius. Sine is the y value divided by the radius. Now we have a couple new ones. Tangent is the y over the x value, or sine over cosine of the same angle. You can't have any of these without angles. They're stuck together. Secant could be of an angle, the radius over the x value, or you could call it 1 over the cosine. A couple different ways to view it. All right, back to my picture. So I want to demonstrate that the way I labeled my picture is correct. So to do that, I just want to think about similar triangles. So we're going to do a little geometry here. So I have this red triangle. There's theta. There's a right angle. Here's my y value. Here's my x value. The green triangle is the same shape, it's just bigger. We have the same angle theta here. It's just that this horizontal is longer. Instead of x, I'm going to go with the unit circle, it's just 1. So I'm going to say that's 1. And then I'm going to put a question mark for that opposite side there. When triangles are similar, ratios of sides are in proportion. So what that means is on the big triangle, if I take the side opposite the angle and divide by the side adjacent to the angle, that means I have question mark over 1. That has to be equal to the opposite side over the adjacent on the red triangle, which is y over x. And y over x is how we define tangent. So tangent has to be the length of that side there. We can do a similar proportion to show then that this length over here has to be the length of the secant of that angle also. There is a way to get some other trig functions out of this picture, but then it gets too messy, so I'm not going to go that far. But I think it's kind of cool that if you do draw a perpendicular from where the circle intersects the axis, and then you extend the ray for that angle, that new vertical height that you created is the tangent. So the most popular 3 trig functions are sine, cosine, and tangent, and we can easily show those in the first sector of the unit circle related to the angle. All right, so again, more things to commit to memory. What is the sine? What is the cosine? What is the tangent given an angle? And then the other thing you want to keep working on is memorizing the first quadrant of the unit circle, those special angles and radians, and the corresponding x and y values. Because given those and those special angles, I can now tell you what is this cosine at any one of those angles, what is the sine. And now that I know tangent is y over x, I can tell you what the tangent of each of those is. All right, so let's do that next.